Alright, so this is Wiley problem 6b. It's D. Okay. So 6b, and it is dehydration of cyclopentanol. Alright, so I just drew out the cyclopentanol molecule. Alright, so in order to answer this, I had to do some background checkup. So this was background info. And okay, so I got this from page 436 in the Solomons and Friel Organic Chemistry 10th edition, and it was 9.16 D, and it is fragmentation by cleavage of two bonds. That's the title of the section where I had to get this information from. Alright, so they talk about alcohol. It says alcohols frequently show a prominent peak at M minus 18. So this M by itself, the M plus minus, is the unfragmented whole molecule. It's the entire molecular weight. So if you subtract 18, 18 is the molecular weight of water, right? When we're talking about dehydration. And what they're saying is that alcohols frequently show dehydration. They lose a water molecule during fragmentation. So they say, alright, obviously this corresponds to the loss of a molecule of H2O, right? So here they show us the mechanism. I know we've seen this mechanism before in these Wiley problems, but going over them like 500 times won't help. Will help. Alright, so they give us R attached to CH. And here, this CH is attached to an H up here. To CH2, and the CH2 is attached to an alcohol that has had its electron removed from ionization. The hydrogen here gives one of its electrons to the oxygen, one of its electrons to this bond right here, and then this bond gives both of its electrons to the OH, so it cleaves and breaks off, and then you're left with RCH CH2 plus H2O, and this corresponds to the M plus dot minus 18, right? Because it's this minus the water, which is 18, so it's minus 18. Alright, so now they say which can also be written as, this is a point like it's a little confusing, and you'll see this is, I used it to answer the thing in Wiley. Right, so this is our original molecule right here. And then after fragmentation, it goes to RCH double bond CH2 plus H2O. Alright, so this right here where we see this double bond corresponds to up here, this where the bond has the dot and a positive. That came from this going here, and then this became positive because this went up here. Now, okay, so that double bond, that's kind of, I knew in Wiley I had to write, I can't write this in Wiley, I don't think so. And I tried a couple different things. I tried when I was in Wiley, I tried putting like charges where they're supposed to go. But anyway, so this is how I answered. So back to, here's the dehydration of cyclopentanol. Okay, this is, right, this is the not yet fragmented molecule, the not yet fragmented ion or whatever. So, okay, right, so this hydrogen here, one bond away. Notice it's kind of like, okay, so here's the carbon attached to this oxygen, one carbon away. The hydrogen attached to one carbon away that is attached to the OH bond is the one that donates its, it donates one of its electrons to this oxygen, one of its electrons to this bond, and then the carbon that's attached to the hydroxyl group here donates both of its electrons, so that breaks off. And now you get left with this, right? Now this kind of makes sense that here this gave up both of its electrons, so that's where the positive is, and this electron right here went to kind of like around this bond, so it's right there, which is the way that they write it up here, right? Plus H2O. Now in Wiley, so the other way to write this is putting the double bond and then the brackets with the positive. It's, you know, the positive fragment. So in Wiley, what happened was, this is, Wiley doesn't have these brackets showing like this, so it was a little confusing. You just, I guess, have to imagine that they were there. So I just put I just made cyclopentane with the double bond, and I thought like maybe putting, I guess the positive now is just distributed between everything. So none of these carbons are positive. I tried making this positive or this positive, and it didn't work, and I kind of think it's because the positive is just distributed everywhere now rather than just on this carbon right here. And then it also asks for the charge. It's just +1, right? Because you lost, maybe I don't exactly know 100% why it's +1. And then they ask for the MZ, the mass to charge ratio of this molecule, So it has 5 carbons, right, times 12, plus 8 hydrogens. 5 times 12 is 60, plus 8 equals 68. And those are the answers. All right, moving on.